Hello, please confirm, is my screen visible?
Yeah, it's visible.
Okay, thank you. Okay, so last class we saw last class we covered field completely. Then I also taught theory about vector space, and I gave some examples. So this class the plan is I will give more examples on vector space, and also we will cover vector subspace. Okay, these topics will complete today. See some vector space examples. Not vector space examples. I will give you some questions and you need to check and tell whether it's a vector space or not. Now verify whether the following sets qualify as vector spaces over the field or verify. I'm going to give some sets. You need to verify whether they are vector spaces or not. First question is I'm giving vector space of x1, x2 and 1 for all x1 x2 belonging to real numbers. Now I'll give 4 questions. Some you please keep solving and tell me, then we'll discuss one by one. Okay. Yeah, for this you need to have attended the previous class. I've given proper explanation. Please try. You need to check all the 8 conditions. There are 8 conditions. Please check all the 8 conditions one by one. Even if one condition is not satisfying, then you can say it's not a vector space.
First one is not a vector space. Then
what is the reason?
x1 x2 இப்போ சப்போஸ் நம்ம ரெண்டு வெக்டார்ஸ் எடுத்தோம். இப்போ x1 x2 x3 x4 அந்த தேர்ட் டிபிள் வந்து 1 1 இருக்கும். இப்போ நம்ம v1 + v2 = v2 + v1 belongs to v ல தான இருக்கணும். பட் x1 x2 x1 + x3 x2 + x4 1 + 1 வந்து 2 ன்னு தான வரும். அது வெக்டர் ஸ்பேஸ் செட்ல இல்ல.
Very good. That's it. Okay. So I'll write whatever he said as explanation. Don't worry. So try this question. Just write some questions and then I will start explaining. Okay, solve these 3 questions, then we will continue. Can you give answer for second question? Is it a vector space or not? Third question also someone try. I'll give you 2 minutes, then I'll explain. Yeah, any answer can I get? Okay, not a problem. I will show the explanation.
Vector space.
Second one vector space. Okay. Third one?
Third one enna podala.
Okay, you do third one later. I'll finish first 2 first. So as Gautam said, so first whenever you want to verify whether a vector space is vector space over given field or not, you will assume 3 vectors. Let v1, v2, v3 belong to vector space and alpha comma beta belongs to the field. Field is real numbers here. Okay. Now what we can do is actually third condition is identity element. What is identity vector for this? We'll have identity vector 0 0 0. If you observe carefully, identity vector is not a part of vector space. So we can say that third condition is not satisfied. Because one condition is not satisfied, you can say that this is not a vector space over the given field. Even first condition you can solve as Gautam said. What Gautam said is let v1 we can take it as I'll take it as a1 a2 1. I'll take v2 as b1 b2 1, and if I am adding both these, I will get v1 plus v2 will be a1 plus b1 a2 plus b2 and 2. Now what is the condition for element to belong to vector space? I should have third component as 1, correct? So if third component of any vector like this is 1, it will belong to the vector space. But unfortunately, when we are adding v1 plus v2, we are getting third component as 2. So we can say that v1 plus v2 does not belong to vector space. So we can say first condition also is false. So two conditions are false. Even if actually this one condition is more than enough to tell. Anyway, if you check second condition also, it is very good. It will definitely not be a vector space. Okay. So I hope if any doubt, anyone has any doubt, please stop me and you can ask me. I'll definitely clarify your doubts. Now, second question, if you're observing, second question is actually a vector space. Second question is a vector space. So if you're seeing first condition is you should have b1 plus b2 equal to a1 plus b1. All this you need to add. Just 1 minute. I think if you have forgotten, then I will show what I taught last class just for revision. The notes from last class. These are the 8 conditions. If you observe carefully, first condition is commutativity closure. v1 plus v2 should be equal to v2 plus v1. It should belong to vector space. So if you observe carefully, definitely when you add x1, suppose you are taking one vector, you just check it yourself. No, why should I check this condition? This question try on your own. If you observe carefully, all the 8 conditions will be satisfied. Okay. I'm writing bracket with respect to normal multiplication, with respect to normal addition and scalar multiplication. Last class, if you understood fully, you can do this question. I know, leaving it to you. This question, anyone got answer? First of all, does anyone want explanation? Second question, because it is a very direct question. One explanation I'll give. All 8 conditions will be satisfied. Tell me. Yeah, hello. Anyone wants explanation?
Third is not a vector space.
Huh? Third is not vector space. Third is not vector space. Can you give me the reason why it's not vector space?
Like if we we can assume that with the first property that x1 is some value and the x1 plus 1 is some value and add two vectors, we will get like x1 plus something, and for the fourth part of the matrix, like the 2 into 2 part of the matrix, you will get
2 here, correct?
2 here. Yeah.
That is one reason you can say. So if you observe carefully, this is one.
Correct reason இல்லாத மாதிரி இருக்கு எனக்கு. இப்போ x1 plus x2, x1 plus x2 plus 2 இருக்குல்ல. அது வந்து நம்ம x1 plus x2 plus 1 அது வந்து ஒரு தனி நம்பரா இருக்கும்ல. plus 1 இன்னொரு நம்பர். So அப்பயும் அந்த கண்டிஷன் satisfy ஆகும்ல.
Actually what Gautam said is correct. I just wanted to tell that only. So but still it's not a vector space. I'll explain what Gautam said anyway. But if you observe carefully, this condition is not there, right? Third condition states we need to have identity matrix. Third condition states we need to have identity matrix. Third condition states identity. What is the identity matrix for this condition? We need to have 0, 0, 0, 0. Correct? Is it a part of this vector space? Suppose you are putting x. See this. You have to. If you want to check whether it's in this vector space or not, you put x1 is 1. Suppose you are putting x1 is 0. You are putting x2 is 0. Then what is the matrix you will get? You will get 0, 0, 0, 1. You will get. You won't get this, right? So identity matrix is not there. It's not about a vector space. So with this condition itself, you can say it is not a vector space. Clear? But anyway, what Gautam said, it is actually I was thinking about it again. It's I'll explain what Gautam said. So to take condition 1. Condition 1 stage, you take vector 1. I'll take it as x1, x2, 0, x1 plus 1. Vector 2, I'll take it as y1, y2, 0, y2, y1 plus 1. Now what I'll do? I will add both these vectors and I will check whether resultant vector is a part of vector space. So I'm doing v1 plus v2. v1 plus v2 will be x1 plus y1. This will be x2 plus y2. This will be 0. This will be x1 plus y1 plus 2. This is not a vector space. I'll tell you why. Listen carefully. I'll take this value as z1. I'll write. Let z1b equal to x1 plus y1. I'll take z2 equal to x2 plus y2. So if I'm putting this, what will I get? I'll get v1 plus v2 will be z1, z2, 0. This will be z1 plus 2. So Gautam, you cannot group it like what you said. Because
okay, bro.
What z1 is here, that should come exactly. What z2 is here, that should come exact. That should be here. If you want, but this is not equal to required format. We want this format, but this is not coming. So even first condition is not satisfied. Group this separately. You can't know whatever grouping you said is not possible. Okay. If you are having any fixed constant, then definitely you can say it is not a vector space. Okay. No fixed constants allowed. I hope this is clear. Okay. We'll go to next example. View the heading as polynomial vector space. Polynomial. Here I'll prove all the 8 properties properly. Okay, so that it's the revision of last class and people who didn't see last time recording, they can also follow. So what I'm saying is I'm giving vector space V. I'm telling all real polynomials of degree less than equal to D. Okay, and I'm saying field is R, and I'm asking whether it's a vector space or not. Okay, so how to do it? First, you frame V properly. Vector space I've written in English language. First, you convert it into mathematical language. Then we will check whether it's a vector space over the given field or not. So I'll write V as a0 plus a1x plus a2x squared, so on till ad x power d. For the elements, they should belong to the given field, correct? So if you have seen last class, you can say that field is the building block for the vector space. From the field, this a1, a0, a1 till a2, ad, and you will put it as coefficients of the variable x, powers of x. Okay. So now our aim is to check whether this is a vector space over the given field or not. So I will do this full question. Okay. So how to do it? We'll assume first we have to define addition multiplication. So I'm defining. I have got 1 minute. I will write. Okay, defining addition like this. Suppose I'm saying for addition, first I need to define what the vectors are. I tell let vector 1 be equal to a0 plus a1x plus a2x squared, whatever. Let v2 be b0 plus b1x plus b2x squared, whatever. Let v3 be equal to c0 plus c1x c2x squared till cd x power d. All these three, because they are the required format, they belong to vector space. And I'm assuming let alpha comma beta belong to the field R. And what is this? These are scalars. And these are vectors. So now I need to check each property. First I have to define addition multiplication. So I'm defining addition like this. v1 plus v2 will be, you're adding corresponding coefficients, a0 plus b0 plus a1 plus b1x, like that. Then I'm defining multiplication as alpha into v1 will be, you are multiplying alpha into each term. Okay. So first, whenever you are talking about vector space, first you define the two operations, plus and into, only then you can proceed. Now we will try to understand whether it's a vector space or not. What is first condition? First condition states that v1 plus v2 should be equal to v2 plus v1 and should belong to vector space. So if you do v1 plus v2, you will get a0 plus b0 plus a1 plus b1 x, like that, till ad plus bd x power d. If you do v2 plus v1, you will get b0 plus a0 plus b1 plus a1 x till bd plus ad x power d. Now, if you are observing carefully, now you see examination you should write because addition is commutative. You should write this step. You can say V2 plus V1. You can change this order. A0 plus B0 plus A1 plus B1 till AD plus BD x per D. And I can say this is same as 1 plus V2. Also, I can say both this they belong to vector space. See, this is I can take this as C0. I can take this as C. I can take this as C0. I can take this as C1. I can take this as CD. They are in the required format, correct? I should have something plus something x, something x squared, something x per D. Observe carefully. Something into x, something into x per D. So it is in the proper format. I can say this belongs to vector space V. So I can say first condition is satisfied. Okay. Second condition will be V1 plus V2. V1 plus V2
Man,
plus
wait.
V2. What?
Wait. I have a doubt.
Please. Don't talk. Tell me the doubt. What is the doubt?
What if AD plus BD is 0? Won't it change the degree of the equation?
Good question. That is why I have given all real polynomials of degree less than or equal to D. I didn't say degree D. I said less than equal to D. See properly.
Now I'm clear.
Okay, it can be if this is 0, then and you're having a d minus 1 is not 0, and degree will be d minus 1. You're having everything 0, degree will be 0, degree will be 0. That's also accepted. 0 less than equal to d. That's why I was very careful. I gave less than equal to. Okay, not a problem. So v1 should be equal to v1 plus v2 plus v3. So I think you can prove this. Okay, this is just associativity. This you try on your own. Okay, this will be satisfied. What is the third condition? Third condition is you should have identity. No presence of identity vector, correct? So what I'll do? I'll tell v1 plus identity vector vi should be equal to identity vector plus vi should be equal to v1. What I'll do? I'll take these two equations. If I take these two equations, v1 will be a0 plus a1x plus a2x squared till ad x power d plus vi should be equal to a0 plus a1x plus a2x squared till ad into x per d. Now you can take all this side, you can do cancellation. So you do cancellation, you will get vi will get us 0 plus 0x plus 0x squared till 0 x per d. Now you tell me, is this vector part of vector space or not? Here you are having a0 as 0, you are having a1 as 0, you are having a2 as 0, you are having ad as 0, all zeros. So thing is that this is allowed, right? This is allowed in vector space. So I can say that this is the identity vector. I can say identity vector belongs to vector space. So I can say condition 3 is satisfied. Condition 3 is anyone know? You observe this. Condition 3 is identity element 0 should be part of vector space. So I have proved that identity vector is a part of the vector space. Okay. Anyone has doubt, you can stop me and you can ask. Okay. So I'll proceed to fourth condition. Fourth condition is inverse element. So inverse element, what I'll do? V1 plus inverse should be equal to inverse plus V1 should be equal to identity element. Okay. So if I take these two conditions, I can say V1 plus V inverse should be 0. So I can say V inverse will be V1. So I can say V1 can be written as, VE can be written as minus A0 plus minus A1 into x plus minus A2 into x squared till minus AD into x per d. Okay, observe carefully. This also belongs to real. This belongs to real. All are real numbers, right? So what is the condition for the element to belong to vector space? You should have like this. And all of them should belong to R. That condition is satisfied, right? For all elements in V, this will also belong to real, this will belong to real. So I can say V belongs to vector space always. So I can say fourth condition is satisfied. This is only present. Why I'm writing this question like this is you have to know how to present in the examination. Exact same steps what I written. If you present in examination, you will get full marks. Okay. Next, if you take fifth condition is you have to check if distributive is true. That is k1 plus k2 into not k1 into alpha plus beta. Alpha plus beta times v1 is it equal to alpha v1 plus beta v1? You need to check, and it should belong to vector space. So alpha, so I'll let LHS. LHS will be alpha plus beta into v1. v1 is a0 plus a1x till ad x power d. This will be equal to alpha plus beta a0 plus alpha plus beta a1x till alpha plus beta ad x power d. Okay, and if we take RHS will be alpha v1 plus beta v1. So if you're expanding it, you will get alpha into a0 plus alpha a1 x plus alpha ad x per d. You will get plus beta a0 plus beta a1 times x till you will get beta ad times x power d. Now you can add corresponding elements. You will get alpha plus beta into a0 plus alpha plus beta into a1 x plus alpha plus beta into ad x power d. I'll do proper bracket. I'll put is equal to RHS is equal to LHS. So you can say fifth property is satisfied. This also belongs to vector space because this is real, everything is real. So I can say v1. I can say this also belongs to vector space. Any doubt? This is a presentation I'm showing in the examination. You have to show LHS equal to RHS fifth property. So I know it is very boring. This chapter theory is really very boring. So please bear with me. I know it's boring. It's boring, but even I don't like it. So we need to prove alpha beta into v1 should be equal to alpha into beta v1 should be equal to beta into alpha v1. This I'm giving you homework to try yourself. Okay. This will get proved of this. Okay. This is grouping property. Try it yourself. Okay. Because if I do all property one class, I'll do only one question. Can't do everything. Seventh property is what? Seventh property is you're having 1 into v1 should be equal to v1. It should belong to vector space. So you're having I'm taking alpha as 1. So 1 into v1 is 1 into a0 plus a1x till ad x per d. Now see, it looks very silly, but you need to write this step. Look at this step. I'm writing 1 into a0 plus 1 into a1x till 1 into ad. You need to show these steps. Only then you will get marks. Now 1 into a0 is a0. This is a1x. This is till ad x per d. Now this is equal to v1. This belongs to vector space. So I can say seventh property is satisfied. Hope it's clear. Seventh property clear? Yeah, Gautam, please soltate. Is it clear?
Clear.
Alpha plus beta v1 should. Okay, very good. Alpha v1 plus beta v1. Okay. Exact same way how we proved. I wrote LHS equal to, I wrote RHS equal to. You need to sit and prove. Okay. LHS will be what? LHS will come as alpha plus. Oh, same thing I wrote here. Oh, sorry.
Alpha
this is 8
v1 plus v2.
Yeah, this is 8th property. Okay. Property doesn't order as I wrote the order wrongly. Sorry. Yeah, fifth property will come here. Fifth property will come as alpha into v1 plus v2. This property. Fifth property will come here. Not a problem. Okay. So you will get alpha into should be equal to alpha v1 plus alpha v2. This is a property you need to prove. So return proof. You do all the steps. I'm very tired. How much will it show? LHS is what alpha into. You write fully. LHS you write. RHS you write. You show they're equal. That's it. They are equal. So I'm saying fifth property is satisfied. Right? 1 minute. This is it is here. That's it. So I'm saying all the 8 properties are satisfied. So all 8 properties satisfied. So I can say it is a vector space. So V is a vector space over field R. Tell me, are all these clear? Know what I've shown? All this polynomial vector space, is it clear? This set what I've written here. This is a vector space over the given field. Okay, it will come as one. I don't know. It may come as 3-4 mark question. All 8 properties you have to prove. They'll give half of mark for each property. I mean, just guessing. I don't know the marking pattern. Something will come like that. All you have to just prove. Okay. All right. With respect to usual plus minus, plus dot. Sorry, plus dot. Okay. Any problem?
No bro. Subspaces போயிடலாம் bro. தூக்கம் வருது இதுக்கு.
What?
Vector subspaces போயிடலாம்.
Just 1 minute. One more. I'll go to vector subspace in another 10 minutes. Okay, 10 minutes I will go to vector subspace. So I'll give you this question for vector space. Verify if it is a vector space. Verify if it is a vector space. I'm giving V will be x comma y. I'm giving x greater than equal to 0, y greater than equal to 0, or x less than 0, y less than 0. Verify if this is a vector subspace. Sorry, vector space over the given field R. I'll explain this question. I don't want to waste time. Already time is less. So this condition, what is the condition? Condition they are saying x comma y should belong to first quadrant or third quadrant. This is the exact condition they have given, correct? This is the exact condition they have given. X comma y, this point should either lie in first quadrant or third quadrant. Now this is not a vector. Now listen carefully. Suppose example, I am taking vector 1 as 1 comma 5. I am taking vector 2 as I am taking as minus 2 comma minus 4. Okay. Now add these two. This is in second quadrant. This is not a part of vector space. Because vector space means in this vector space you need to have either first quadrant or second, third quadrant. But when adding two vectors, they are getting answer in second quadrant. So I can say that the given vector space is not a vector space over the given field. Okay. First property is still not satisfied. First property is still not satisfied. Then how will you tell vector space? Okay. So it is not a vector space. Space over field R. It is properly. Not a vector space over field R. I'll give verify. Certain V will be 0 comma x for x belongs to R. This is a vector space or not? Please solve this question. Tell me whether it's a vector space or given field. Field is R. See, when I'm writing x is R, so I'm telling you that field is R. You don't have to mention because this is the building block. I've already given building block, so this is the field automatically. I won't write extra. Okay, this is a field you have to understood. You have to understand. I'll just wait for an answer from somebody. We'll give some more questions. This is V1. It is a vector space.
Over field R.
Did you check all the properties? All properties should be satisfied. Vector space, I'm giving pakka practice. All concepts you should understand. All this will be true. Okay. For this question, please tell me. Third question, I'll write. V3. V4 I'll write. Please tell me. What are vector spaces which is not vector space? Tell me.
4 மட்டும் வெக்டர் ஸ்பேஸ் கிடையாது. மத்த ரெண்டுமே வெக்டர் ஸ்பேஸ்.
Reason why is 4 not a vector space?
அதுதான் ப்ரோ அந்த இந்த ப்ராப்பர்ட்டி ஃபர்ஸ்ட் ப்ராப்பர்ட்டி.
First property because you will get x1 plus 1, you will get x2, you will get, I'll write roughly here, x1 plus 1, you will get x2 plus 1. When you add, you will get x1 plus x2 comma x1 plus x2 plus 2. This is wrong, correct? Suppose I'm writing this as x3, this will be equal to x3 comma x3 plus 2. This is not a part of vector space, correct? So V4 is not a vector space. Or I can also say identity does not exist. Is not there. So many properties are not there. So I can say this is not a vector space. It's not a vector space over the given field. This will be vector space for sure. This will be vector space for sure. Okay. Now I'll give one observation. This is observation. Until you are able to understand. R squared. All lines passing to origin will be vector space over R squared. Vector space over R. Okay. See, look at this. This path. This is what this is line equation is y equal to x line. So it's a vector space. This is y equal to mx line. It's a vector space. But what is this line? This line is y equal to x plus 1. It's not passing the origin, not a vector space. That's it. So this you can keep in mind, okay? Because only if you're having origin, if you're not having constant like this, constant 1 will become 2. So you can't have the first property is not satisfied, right? So only line passes through origin, you can say that it is a vector space, okay? Get out of this. Get out, please tell. Last question for vector space. Fifth question, giving x comma x squared or x belongs to R. Is this a vector space for given field or not? Please tell me. Observe geometrically, this is y equal to x squared. This is parabola. Please verify if this is a vector space or not. Someone fast, give me answer. Waiting for your answer.
Not a vector space, bro.
Reason?
Like if we take x and y, x square plus y, y square will be getting, but that is not equal to x plus y the whole square.
That's it. Very good. That is property 1. You should tell the property. Okay. Property 1 says v1 plus v2 should be equal to v2 plus v1 and it should belong to vector space. So if you're observing this, v1 will take us x1 comma x1 squared, v2 will take us x2 comma x2 squared. So if I take LHS, I'll get if I get yeah, correct. If I take LHS, I'll get, if I'm adding, it's not LHS, let's just add, I'll get x1 plus x2 comma x1 squared plus x2 squared. But my expectation is I need x1 plus x2 comma x1 plus x2 whole squared. See, whatever x you are having, square it. Whatever is here, I want square it. But this is not matching. That is, I'm saying v1 plus v2 does not belong to vector space. So I can say it is not a vector space. Clear? First property is not satisfied. So even if one property is not satisfied, we'll say it is not a vector space. See, you cannot have parabola, you cannot have any other curve. Only this is allowed. Only line is allowed. Only if you are having line, that too it should pass to origin. Remember these two. If you have line, it's passing to origin. Only this two, it will generate vector space. Clear? Just do one question from the sheet which ma'am gave, and the last question of vector space. I'll move to vector subspace. Okay, just wait patiently for 2 more minutes. Suppose I'm having x comma y. All x comma y belongs to R. What I'm see, this is a normal vector space. This is n tuple. I've already taught n tuple. This is n tuple. Definitely it will be vector space. But the problem is, I am changing the definition of plus and minus. I am saying plus means x1 comma y1 plus x2 comma y2 will be equal to x1 comma y1. I'm saying I am changing the definition of plus, and I'm changing definition of int. I'm saying alpha into x1 comma y1 should be equal to alpha squared x1 comma alpha squared y1. See, I am changing definition. I have a right to change definition. This is my definition. My definition. It's not normal definition. Now I'm asking, with respect to the new definitions I have done, is this V? I'll let us V6. This is V5. Is this a vector space over the given field R? Someone try and tell me which property is getting violated, because ma'am did questions like this. That's why I'm telling. Can someone say? Yes, not getting response. First property is not satisfied. Do not observe. What is first property? V1 plus V2 should be equal to V2 plus V1. You observe. LHS, we will get back V1. We are putting V1 plus V2, we will get back V1. But RHS, we are putting V2 plus V1, we will get back V2, correct? And V1 is not equal to V2. Always. So I can say, first condition is, it is not commutative. Anyone has a doubt on this? Yeah, Gautam, can I stop the recording? I will start this. So I hope what I taught till now is clear. So now I'll stop the recording and we will start with vector subspace. Can I proceed with vector subspace? Are you all comfortable?
Okay.
I'll proceed with vector subspace.
Okay.
I have to go, so bye. I'll just watch the recording.
Okay, sure. Please, you are free to leave whenever you want. Okay, bye bye.